This video is about using the distributive property to simplify expressions, and it's lesson 15 in your book. The distributive property says that for all real numbers a, b, and c, a times the quantity b plus c equals a times b plus a times c, and a times the quantity b minus c equals a times b minus a times c. Now what this means is that if you have a number outside a set of parentheses and it's being multiplied by the quantity in parentheses, you can distribute that term outside the parentheses to every term inside the parentheses. For example, if you have 5 times the quantity 2 plus 1, it's the same as multiplying 5 by each term inside the parentheses. 5 times 2 plus 5 times 1, which is 15. If you have 5 times the quantity 2 minus 1, it's the same as multiplying 5 by every term in the parentheses. 5 times 2 minus 5 times 1, which is 5. All the distributive property really says is that you can multiply the number outside that set of parentheses by every term inside the set of parentheses. Now remember, terms are separated only by addition and subtraction, not multiplication and division. So you want to only apply that outside number to each term once. Alright, so let's try some. Be sure to write these down in your notes because these are examples. First one we have is 6 times 4 plus 8, the quantity 4 plus 8. Because we have the 6 outside the parentheses right here, and then 4 plus 8 in parentheses here, we can use the distributive property to multiply the 6 by each term inside the parentheses. Now, let's identify our terms. This is one term. There's a plus sign in between these two, and this is another term. So we want to multiply the 6 by the term 4 and by the term 8, and we're going to keep our addition. So I'm going to have 6 times 4 plus, because I have to keep my same operation, 6 times 8. Now when I simplify this, 6 times 4 is 24, and 6 times 8 is 48. Finally, I add 24 plus 48 is 72. Now notice I got the same thing that I would have gotten if I followed the order of operations. If I had multiplied, or if I had added 4 plus 8, I would have gotten 12, and 6 times 12 is also 72. Here I have 4 times the quantity 5 minus 3. Because I am multiplying something on the outside by something in parentheses, I can distribute this 4 to each term inside the parentheses. So let's identify our terms. Here's our subtraction sign, so the two things that is separating are our terms. So our terms are 5 and 3, and I can multiply the number on the outside by each of these. So this can be rewritten as 4 times 5, and then minus, because I have to keep the same sign, 4 times 3. When I simplify, of course, I have to do multiplication before I can do that subtraction. So 4 times 5 is 20, minus 4 times 3, which is 12. And then I subtract 20 minus 12 is 8. Again, notice if I had subtracted what's inside the parentheses first, 5 minus 3 is 2, and 4 times 2 is also 8. Alright, let's look at some more. This time we're distributing a negative integer. So instead of distributing the positive, we're distributing a negative, which means the rules of multiplying and dividing negative numbers come into play. Again, these are examples, and they both need to be in your notebook. Over here I have negative, and in parentheses, 9 plus 4. This negative on the outside doesn't have a number attached to it, and whenever we don't have a coefficient or a number attached to a negative, we always have an assumed 1. So this is negative 1 times 9 plus 4. And I want to distribute this negative 1 to each term inside my parentheses. So the two things that are separated by the plus sign are 9 and 4, and I'm going to multiply by negative 1 by each of those. So I can rewrite this as negative 1 times 9 plus, and keep my sign the same, negative 1 times 4. Alright, now I do multiplication. That's the next in my order of operations. Negative 1 times 9. 1 times 9 is 9. Negative times a positive is negative, so that's negative 9. Plus, now I'm going to do multiplication here. Negative times a positive is a negative. And 1 times 4 is 4. Now I know that adding a negative is the same as subtracting, so that's like negative 9 minus 4. And negative 9 minus 4 is negative 13. Again, notice that using that distributive property resulted in the same answer as if we had done parentheses first and then multiplication. 9 plus 4 is 13, and when we multiply it by negative 1, we get negative 13. Alright, here's another example where we've got negative 9 times negative 6 minus 3. Now we can multiply each term in our parentheses by the one on the outside. So we're going to multiply by negative 9. We're going to multiply negative 6. That's a minus, and then 3. And we're going to keep our subtraction in the middle of those two terms. So I can rewrite this as negative 9 times the first term, negative 6, minus, again, negative 9 times the second term, which is 3. Then I'll follow my order of operations. So negative 9 times negative 6, I know a negative times a negative is a positive, and 9 times 6 is 54. And I've got minus. Negative times a positive is going to give me a negative, and 9 times 3 is 27. Now here I'm subtracting a negative, and when I subtract a negative, that's the same thing as adding the opposite. So I'm actually adding 27. And 54 plus 27 gets me 81. A positive 81. Again, notice if I had subtracted negative 6 minus 3 would get me negative 9. And negative 9 times negative 9 is a positive 81. Alright, now let's do some algebraic expressions. So instead of just numbers, these have variables. But they work exactly the same way. I have a negative 4 times the quantity x plus 7. I can multiply negative 4 by each term inside the parentheses. Remember, the terms are what are being separated by plus or a minus. So here my terms are x and 7. So I can multiply negative 4 by each of these terms. I can rewrite it as negative 4 times my first term, which is x, plus, because I need to keep the same operation, negative 4 times my second term, which is 7. Now I'll follow my order of operations and multiply. Negative 4 times x is negative 4x, plus negative 4 times 7, that's a negative times a positive, so I'm going to have a negative. 4 times 7 is 28. Now I want to write this in the simplest form possible, so I want to get rid of this plus a negative. When I'm adding a negative, I'm really subtracting, so I can rewrite that as negative 4x minus 28. Also, the two on this page are examples, and they do need to be written in your notes. For this next one, I have 5 minus x times 6. Now, it doesn't matter that the 6 is on the right side this time instead of the left side. It's still being multiplied by a quantity in parentheses. So again, we can use the distributive property. I can multiply the 6 by each term inside the parentheses. And here my terms are 5 and x, because they're what's being separated by subtraction. So I can rewrite it as 5 times 6 minus x times 6. Now when I multiply to simplify, I get 5 times 6 is 30, minus x times 6 is 6x. Now, this can be written as 30 minus 6x, and that's our solution. Alright, let's do some algebraic expressions with exponents. Again, we still follow all the laws of algebra, but we use the distributive property to multiply the thing on the outside of the parentheses by every term inside the parentheses. Again, these are examples. These both need to be in your notes. Here we have mn times the quantity mx plus ny plus 2p. We can distribute this mn to each term inside the parentheses, so that's what we'll do. We can rewrite it as mn times mx plus, because we keep the same sign, mn times ny plus, again, mn times 2p. Now the only thing we can simplify here, since this is mostly variables, is when we have multiple occurrences of the same variable that are being multiplied, we can use the product property of exponents. So we have mn times mx. Now we're multiplying m times n times n times x. So we have m times m, and we know that m times m can be rewritten as m squared. Then we also have times n and times x. In the second term, we have n times n, which we know that we can rewrite as n squared. So we have an m, we have two n's, n squared, y. And then in our final term, none of these factors are the same, so we're not going to be able to get any exponents here. I am going to move this 2 to the front of the expression, just because we like our coefficients to be in front. So I have 2 m n p. And there is our simplified expression. Now let's look at this next one. I have negative xy times the quantity y squared minus x squared z. I need to distribute this negative xy to each term inside the parentheses. So when I rewrite it, I'm going to have negative xy times the first term in my parentheses, y squared, minus, because I have to keep this same sign here, negative xy times the second term, x squared z. Now remember, when we don't have an exponent, there's always an understood 1 as the exponent. So here I have y to the first times y squared, and I can add my exponents, 1 plus 2, and I get y to the third. So here I have negative x, y to the third, minus, I have a negative times a positive, so I know I'm going to have a negative here. I have x to the first times x squared, 1 plus 2 is 3, so that gives me x cubed, y, z. And finally, I want to simplify this just a little bit more. Because I have minus and negative, I know that's really adding. So I have negative x, y to the third, and instead of minus and negative, I'll write plus x to the third, y, z. And there's my simplified form.